This is section 2.22. We're going to continue examining logarithms. And in this lesson, we are going to convert between exponential and logarithmic form, and then we're going to use that idea to then evaluate logs. So in the previous lesson, we talked about how to evaluate a log, and we asked ourselves, what power do I need to raise that base to get that bigger number inside of our logarithm? Now, that trick will always work, but sometimes we're going to get logs that are going to be in a very awkward form, and it becomes very difficult for us to actually think about what I need to do with it. So to help us with that, what we're going to do is we're going to kind of convert it into an exponential equation to be able to help us. So let's talk about how to convert it between the two. So since we know that exponents and logs have this inverse relationship, we can use a log to cancel out an exponent, or we can use an exponent to cancel out a log. So for example, if I wanted to cancel out that 2, it's a base 2, I would take log base 2 to both sides. Now that log base 2 and this 2, that's going to cancel out because they're inverses of each other, and you're going to be left with x. So I originally started with an exponential equation, and I converted it into a logarithmic equation. So same here. There's my base of my exponent. So to cancel that out, I would do log base 10 to both sides. The log base 10 and the 10 will cancel out, and so I'm left with a log. If I have e to the t, e is my base, so I can take log base e to both sides. The log base e and the e cancel out, and so I get t equals log base e to the 70. So to get rid of the exponent, take that log to both sides. Now likewise, I can convert a log to an exponential equation. And so we examine the base of the log. In this case, it's a 2. And so base 2 to both sides is what's going to cancel out. Now, it's a little weird because this is an exponent now. This is 2 to the log base 2 of 32 power. Right? This becomes the base, this becomes the exponent. So that's the way I'm not multiplying by 2. You got to be very careful with that. We're not multiplying by 2. We converted it into an exponent. And likewise, this becomes 2 to the 5th. Now that base 2 and the log base 2 cancel out, so I get 32 equals 2 to the 5th. Same thing here. I identify the base of the log. It's base a. So if I take base a to both sides, or convert it into an exponential equation, now the a and the log base a cancel out. Same thing here. Base t, so I can take base t to both sides, t to the x equals, now they're going to cancel out there, and so I get equals m. So why did we need to know how to convert between exponential and logarithmic equations? Well, we first initially looked at this and we were like, okay, what power do I need to raise 6 to give me 216? Okay, so I could raise 216 in 6 to the 3rd power. Those are going to cancel out, and I'm going to get 3. But I can convert it into an exponent as well, and you'd be able to solve it from there. So log base 6 of 216, what we do is we say it equals some number. I don't know what that number is, but I know it equals some number. And then I could take base 6 to both sides, and so I get 216 equals 6 to the x. So 216 is 6 to what power? Well, that's 6 to the 3rd power. And then I get 3 equals x. Now you might be asking yourself, wow, this one is way easier. So why do I need to know how to be able to convert it into an exponential equation? That's a good question. So let's look at a problem like this. Log base 1/3 equals 1 over 243. Yikes. So we can say it equals some number. I don't know what that number is. And so whatever that base is, it's going to be base 1/3. So I can convert it into an exponential equation. So I get 1 over 243 equals 1/3 to the x. So now I have to think, how can I manipulate this to where it's going to be either like 1/3 to some exponent, or, I can move the 3 to the top. So that becomes a negative exponent. So that means, how can I rewrite 243 in terms of 3? Well, that's, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3, so that's 3 to the 5th is 243, so that's 3 to the 5th. I can move that to the top. Now that the x bases are the same, you can set the exponents equal to each other. And so then I get x equals 5. Same thing here. Don't know what that equals, so I can take base 216 to both sides. So I get 6 equals 216 to the x. I have to make these the same bases. Well, this is 6 to the 3rd. You just multiply it with that. Now that the bases are the same, divide both sides, so I get 1/3. So just know it's going to be 1/3. So like I said, you're not going to have to use this every time. But for the logs in which we can't think of it, like this one here, it's very, very useful. And whenever you see the exponent and the base, they're just going to reduce. So what did we learn today? We talked about how we can convert between logs and exponents. And then we used converting a logarithm into an exponential equation to be able to evaluate. Now, what's the difference between a logarithmic and exponential form? Well, logarithmic has a log in it. Exponential has an exponential in it. That's how we can tell the difference. And then what did we do to the logarithm to evaluate? We converted it into an exponential equation. This does conclude our lesson. If you have any other questions, please leave them in the comments.